Yes, good morning friends. Welcome to the session once again. I hope you all are doing good. Today, as you know, we are going to discuss oceanography. Oceanography. Today we are conducting the second part, okay? Second session. Each session in my YouTube session consists of 40 minutes. Today we are taking up the part 2. Yesterday we have already seen the part 1 of oceanography. Yesterday in our discussion, we have started with the basic understanding of what is the topography, ocean bottom topography. We have entered the session in island arc. Okay, so today we will continue from that particular point. But before we go into the session, I have some information to be met from the Unacademy platform. That is, you see here. Unacademy platform always comes up with certain kind of programs or courses depending upon the upcoming exam. One of the example is in the last year, Unacademy's last mile program was there, and these are the successful individuals who attended that particular session. Not only this, but from all Indian rank 1 to 27 learners were there from the last mile program from the Unacademy in all Indian rank 1 to 20. 20 learners were there in all Indian rank 21 to 100, and also 143 learners were there in all Indian rank 101 to 761. So it is a proof. Okay, now if you also want to be a part of the successful candidate and want your name to be there, you can enroll to the courses which are getting launched in the Unacademy platform, such as Plus Compo subscription, Plus GS subscription. Now, one price hike was expected on 16th, but because of the popular demand, it has been extended to 23rd of December. Okay, because of the popular demand. So you kindly subscribe to this and try to get the discount benefit. Okay. Also, if you go for every 1 year and above subscription for either of the course, you will get a 3-month extension. 3 months is quite a long time. 3 into 30 results in 90 days. 90 days is a very good amount of time. Clear, you will get a free extension. Okay. Now, your prelims is just 6 months away in the month of June. That is for 2022. Taking this into consideration, you have this Mission 22, that is comprehensive batch courses for GS. Also, if in your timeline, if you are sitting for 2023 exam, the courses are available, that is Mission 23, also Lakshya 23. Not forgetting this Lakshya 2022 is also there in the platform. Nothing like preparing for your prelims or revising the topics that you have discussed via this MCQ. Taking this very seriously and understanding its importance, the Unacademy platform has come up with this free test series that you have. The recently introduced is Mrunal's Monday, that is 20 MCQs in 20 minutes. It is available both in English and Hindi every Monday at 8 p.m. Similarly, we have this T20 Current Affairs CS and Abhiyan. In both of this, you have 15 MCQ in 15 minutes. Also, it is available both in English and Hindi. Timing is different. For this T20 Current Affairs, kindly mark this Monday to Friday, 7:30 p.m. For this Abhiyan, it is Monday to Friday, 10 a.m. Okay. For all of this, you can use my enroll code. That is SUNEP 10. Right? Now, one of the best I can say, you lose nothing, you gain. Okay, there is nothing in life where you don't lose anything but only gain. And one of those programs is UPSC Mega Combat. You see here, you just have to give 1 hour of yours. That is 60 minutes. Now, the benefit, number one benefit is UPSC exam is no longer a university exam, college exam or school exam. There is no pass mark in UPSC. It is a competitive exam based on the merit, based on the number of vacancies. The top ranking will be selected. So there is no pass mark. Therefore, by attending a MECA compat like this, you will know at what level or what stage of preparation you are. Thereby, you will be able to self-assess yourself. Okay, that is one. The other point is, you are getting a lot of benefit. You will get a scholarship, as well as you will get amazing gift. Okay, 1000 lucky participant to win an exciting gadgets and a gift voucher. So what you lose nothing, you only gain. In terms of knowledge, in terms of your self-assessment, and also in terms of your good gift as an encouragement. Okay, so for this, every Sunday it conducts. So tomorrow, that is 19th of December, don't miss it, 11 a.m. Kindly go and attend. It is for your benefit only. Okay, you can use my enroll code, that is SUNEP10. Okay, kindly do so. Anyways, chalo, let us continue with the discussion where we have left yesterday. We are discussing ocean bottom topography. Okay, yesterday also I have mentioned, just as we are just in the climatology also, we first try to study the structure of the atmosphere or environment that is surrounding us, because that is the subject matter of climatology or for climate. Similarly, in oceanography, we are going to study the ocean ecosystem. Therefore, in order to study the ocean ecosystem, it is very, very important that we have a proper understanding about the topography. Therefore, right now we are discussing the ocean bottom topography. One of the important feature of ocean bottom topography is island arc. Formation of an island arc, we have already discussed it under our geomorphology. In a very simple way, let me tell you. Kindly follow the pointer. Whenever two oceanic crust comes against each other, converging. Now, both of them are oceanic crust. So, if one is continental crust, one is oceanic crust, it is very, very clear that the oceanic crust is heavier, so it will subduct below the continental crust. But whenever both are continental crust, even then, one will be a little bit heavier compared to the other. So the heavier one will subduct below the lighter one. Whenever this oceanic crust subduct below, what happens is, you see here, it is going towards the interior of the earth. Therefore, temperature increases, pressure increases, melting of this oceanic crust will take place. When it melts, where is the possible route with which it will release the energy? The only possible route is it cannot go below. Only route is upward. So therefore it comes out in the form of volcanic eruption. Thereby, since it is an oceanic crust surrounded by water everywhere, and the volcanic peak which comes out in the water is an island. And this type of island which is formed in the arc shape is known as an island arc, which is very, very clear, which we have already seen. But one very, very important point that you need to know is, this particular island arc, if you see very closely, it is composed of two parallel arcs. What are these two parallel arcs? Okay, you see here. This is oceanic crust. This is oceanic crust which is coming. Now it is subducting below, therefore melting coming up. So this arc is formed, known as a magmatic arc, means because of the volcanic eruption. But you see here, whenever these two oceanic plates are coming together, coming against each other, in the oceanic plate, you have sediments. These particular oceanic sediments, whenever this oceanic crust and this oceanic crust are coming towards each other, these sediments which is there over the oceanic crust will be also subducted. And also first it will be compressed. Okay, first it will be compressed. The sediments will be compressed, will be folded, and formation of a mountain will be there. Fall mountain type of structure will be there. You see here. These sediments which is there on the oceanic crust will be compressed, will be folded. Therefore, any island arc that you will find, it will have two parallel arcs. The outer one is known as It is because of the sediments. This is the outer one. The sediments, they are folded. Because of folding, this type of an arc is again formed, and it lacks volcanic activity. Why? Because this type of folding, this type of peak is because of the folding of the sediments itself, not because of volcanic activity. But the inner arc is purely because of the volcanic activity. So the entire island arc, if you go and see, it will have two particular parallel arcs. One is the outer one is the folded one, and the inner one is the volcanic one. Clear? Let us see some example. Outer arc may have different form. This arc, you see here, one oceanic crust, other oceanic crust coming. If this oceanic crust is subducting below like this, here the sediments will be folded. It will come up like this, fold mountain. Because of this subduction, melting, volcanic activity, another double arc. This is outer arc, this is inner arc. The outer arc has different forms. One, it may be a submerged form, and this you will find in south of Java. Number two, it may be poorly developed. Example, Antilles and Barbados, where it is. Third one, it may be very, very dominant, which you can see. That is Ryukyu Island between Japan and Taiwan. Okay. Topographically, structurally, it may be fused. Means the outer and the inner island arc may be fused topographically or structurally with the inner arc, which is known as, which you will find in a region like Japan. The island of Japan is nothing but an island arc. And in this, the two parallel island arcs are topographically and structurally, they are fused together. So that is the characteristics of this outer arc. You see here, let me tell you one point. Understanding of island arc, just by understanding of island arc, that is not enough. If you feel happy like I have studied everything which is related to island arc, just by knowing that it is formed because of the subduction of oceanic crust and coming out of the volcanoes, it is not sufficient. Okay, so kindly expand your learning, expand your knowledge base. Why? Because let me tell you once again, it is very, very important. The island arc is mainly composed of two parallel arcs. One is of course because of the volcanic activity. The other one, which is known as the outer island arc, is because of compression and the folding of the sediments which was over this particular oceanic crust. And the outer arc is having different forms. We have seen one by one. Submerged one, it may be submerged. You may not be able to see now, but it is there, but it is submerged below the water. Second, poorly developed. Example, Antilles, Barbados. Third, dominant, Ryukyu Island between Japan and Taiwan. Fourth type, topographically, they may be fused together and forming one single arc. But if you go and see structurally, they are actually fused. Let us go and see one by one. You see here, Ryukyu Islands. What is the example of this? They are very, very dominant. Okay, between Japan and Taiwan. This is nothing but the outer arc. Very, very dominant. Ryukyu Island. Kindly mark in your atlas. Very, very important. If you follow, if you listen to me, it will really help you in exam. If you don't listen, you will regret. Okay, very, very important. Kindly mark in your atlas. What is this? Antilles, Barbados. All of this is here. Kindly mark the region. Greater Antilles, Lesser Antilles. Okay, all of this region. Barbados. Okay, Caribbean islands. Japan. They are fused together. Now, this is island arc. This is the continental land, China. Now, you kindly focus here in this region. Okay, we are going to discuss something in this region. This is Pacific Ocean. This is island arc. Why? Because you have a plate boundary here. Oceanic plate coming together. The Pacific one was heavier, so it went down. And formation of this island arc, which is nothing but the Japan. Now you kindly focus here. Marginal ocean basin between the island arc and continent or parallel island arcs. that is Philippine Sea, is known as marginal ocean basin. Between continent and island arc, the water body which is here, it is known as marginal ocean basin. Or it may be between two island arc itself. That situation you will find in the Philippine Sea, Philippines region. Now, in this marginal ocean basin, important characteristics is they are more than 2 kilometers deep, they are transitional basin, they are overlain by a thick sedimentary deposits. Okay, back arc basin also it is called. Okay, back arc basin. Okay, back arc basin is nothing but you see here, whenever this particular volcanic activity, island arc, this is ocean, this is towards continent, this water body is also known as back arc basin. Remember, back arc basin, island arc, continent. Okay, marginal seas, Red Sea, Gulf of California. Kindly go and mark in your atlas, where is the Red Sea area, where is the Gulf of California, rifting of the continent. Okay, even Arctic region, they are marginal sea. Why? Because they are in a transition from sea to becoming an ocean. What is the geology? What is the interior? What is the dynamics which is going on in the interior of the earth? And why this rifting is happening? Why the transition from sea to the ocean? We are not able to explain here because of paucity of time. That's why I have plus course in Unacademy platform. There we can interact very efficiently, and also we get sufficient amount of time. There we explain everything in detail, so you can kindly come and join me there in plus course under Unacademy platform. Okay. The next important landform in the ocean bottom topography is microcontinent. Microcontinent is nothing but it is just like a plateau in the land area. See, in the continental area, that is in the land, we have plateau. What is a plateau? Plateau, in a very simple definition, we can say it is a raised, upraised land. That is a plateau. Similarly, in the ocean bottom also, you have a upraised landmass, huge landmass. Such kind of a landmass is having a dimension up to 1 to 2 kilometers, but do not reach the ocean surface. So you have a huge upraised landform, but which is not above the water body, but beneath the water body, but having a huge tract of upraised landform in the ocean. That is known as microcontinent. Similar to the plateaus that you will find in the land area. You will find like this. This is nothing but the microcontinent, which is below the sea level. That's why in the first session itself, I've already mentioned to you, oceanic topography or ocean bottom topography is as diverse as the land topography, or it can be even more diverse. Okay, very important. Now, with that basic understanding, with that basic understanding of the ocean bottom topography, since yesterday we are discussing about ocean bottom topography, let me just take you through. We have studied right from what is continental shelf, what is continental slope, what is submarine canyon, what is turbidity current, what is continental rise, what is trench, what is MOR, what is abyssal plain, what is abyssal hill. We have seen what is seamount, what is guyots. Today we have seen island arc, different marginal seas, back arc basin, so on and so forth. With that basic understanding, let us go and see different types of ocean bottom relief that you will find in different ocean of the world. Number one is the Pacific Ocean. Now you kindly go and see. The figure is in front of you. Kindly see the diagram in front of you. This is Pacific Ocean. What is the main feature that you will observe in the Pacific Ocean bottom relief? We have seen everything, all the terms which is required, All the different landforms which is required, we have already seen right from yesterday till now. Now you just look at the diagram which is in front of you and try to come up with what is this. Clear? See, in the Pacific Ocean, you see, one of the important characteristics of the Pacific Ocean is there is no central ridge. What is central ridge? That is the mid-oceanic ridge, MOR region. During our ocean bottom topography, we have already seen what is MOR, mid-oceanic ridge. But it is absent in the Pacific Ocean in the middle. We have also seen yesterday regarding what is ridge and what is rise. Okay, you kindly go and see the yesterday's video. You will find the basic difference between what is ridge and what is rise. We have seen whenever the velocity of the divergent plate in the MOR, whether it is fast, slow, the slope which is made, if it is a very steep slope, it is called ridge. If it is a very gentle slope, it is called rise. And the steep slope results because the velocity of this divergent plate is very slow, but the rise happens when the velocity is very high. Therefore, yes, you don't have central ridge in the Atlantic Ocean, but you have East Pacific rise. You kindly follow the pointer. East Pacific rise on the southeast part of Pacific Ocean. You see here East Pacific rise. Okay, now this is a spreading center, you can say. On the east of this, you have this albatross plateau. Okay, albatross plateau. Kindly mark the term, name, albatross plateau. It is known as albatross plateau. From your mapping as well as from your mains, it is very important. Albatross plateau. Another important characteristics is in the Pacific Ocean, on the western side of Pacific Ocean, you have wide continental shelf here. You have continental shelf here. In the Australian region, in the eastern part of Australia, you have this continental shelf, extensive one. It is known as Arafura continental shelf. Here also you will have extensive continental shelf in the western part of Pacific Ocean. Okay, here and in the eastern side of Australia, that is the western part of the Pacific Ocean, where you have this extensive continental shelf, it is known as Arafura continental shelf. If you come to the eastern side, you don't have a continental shelf that much extensive. What is the reason behind that? The reason is very simple. Why? Because here you have a mountain range, and this mountain, Rocky Mountain system you have. At the same time, you have a trench formation. You see here, Peru-Chile trench region. Therefore, you don't have an extensive continental shelf in this region. Therefore, you don't have this deep sea fans are missing on this region. Clear? That is another important characteristics. The abyssal plain that you have in the Pacific Ocean, two of the important abyssal plains are Pellenshuasen abyssal plain that you will find in this region. Pellenshuasen abyssal plain. I am not explaining to you what is abyssal plain again. Why? Because we have already discussed yesterday. In the northern side, you also have this Aleutian abyssal plain. Okay, and here you will have a continental shelf. You have Aleutian trench in this particular region. In the northwestern side of the Pacific Ocean, you will have lot of coyotes and seamounts. Hawaiian Island is also part of this. You have lot of coyotes and seamounts on the northwestern side of the Pacific Ocean. In fact, it is in the world, if you see in different ocean, it is highly concentrated, or the density of or presence of coyotes and seamount is quite high in this particular area. Coyotes and seamounts you will find here. Okay. So as far as the Pacific Ocean is concerned, these are some of the important topography of the ocean floor. Clear? Mary Randall, Sabrina Conan, Judith Wright, good morning and welcome to the session once again. Okay. If you feel like any points are missing, or if you are not able to understand, you can always interrupt me in the comment section below. Okay. The second, let us go and see the bottom relief of Atlantic Ocean. What is the most important characteristics that you will find in the Atlantic Ocean? The figure which is in front of you, it is an Atlantic Ocean. Kindly see what is the most important feature that you will find, or prominent feature that you will find in the Atlantic Ocean. You tell me. The figure is in front of you. You tell me. This is America, North America, USA. This is Africa. This is South America. This is Europe. This is Greenland. One of the most important feature that you will find in the Atlantic Ocean is the mid-oceanic ridge. You remember just now we have seen the Pacific Ocean. In the Pacific Ocean, you don't have a no central ridge, MOR. You have East Pacific rise in the southeast part of Pacific Ocean. But when you come to this Atlantic Ocean, you will have an extensive mid-oceanic ridge of this nature. Clear? So you have mid-oceanic ridge, which is one of the most prominent feature in the Atlantic Ocean. Equator will be somewhere here. Now, in the northern hemisphere, this particular ridge is known as Dolphin Rise. Between Scotland and Ireland, it is known as Wiley-Thompson. Okay, Wiley-Thompson. In the south, it is known as Challenger Rise. Okay. Now, if you go to this Pacific Ocean, you will find trench. You see here, Kuril Trench. Okay, all of this trench you will find. Kermadev Trench. Okay, you will find all of this trench. On the eastern side also you will find trench. On the western side also you will find trench. But when you come to this Atlantic Ocean, the trench are absent. You will not find trench here. It is absent. Another very prominent missing. Trench are missing. But there is some exception. You have a some type of a trench which is known as Atlantic Trench or Puerto Rico Trench in this particular region. Okay, in the Caribbean region you will find one trench. Clear? The description of this Atlantic Ocean is, you see here, it is very narrow in the equatorial region, but it broadens up in the temperate zone in both the latitude, in both the hemisphere, both in the northern hemisphere as well as in the southern hemisphere. One of the important aspect is Romanche fracture zone is present here. Romanche fracture zone. It is a transform fault. Okay. Romanche fracture zone is present here in this region. What is the significance of this Romanche fracture zone? This kind of a fracture or a transform fault which is present allows the easy exchange of a oceanic water from one ocean basin to the other. Yesterday I have already mentioned to you, ocean is a fluid. Water is a fluid in nature, its characteristics. So the mixing will be there. But when you have a relief like mid-oceanic rich region like this, the altitude is even some thousands of meters, hundreds of meters high. If there is an opening in the form of a fracture zone or a transform fault, the mixing of the water is very efficient. And when the mixing of the water is efficient, the characteristics of the different ocean basins are transferred. The transfer of different ocean basin water is important. Why? Because marine plant and animal organism live depending on the oceanic characteristics. What is the salinity? What is the temperature? What is the density? So on and so forth. Clear? You see here, again, this is the Atlantic Ocean itself. One important characteristics of Atlantic Ocean is, again, the presence of extensive continental shelf. In the Pacific Ocean, we have already seen the continental shelf, extensive continental shelf are absent in these regions. Okay, but in the Atlantic Ocean, in both the sides you will have extensive continental shelf. Like here also you will find in Newfoundland area, this is known as Docker Bank, or in this Celtic region it is known as a Grand Bank. And because of having of this extensive continental shelf, you will also have submarine canyons in this. Actually, there is a very important, sub or ocean cable, okay, network, telecommunication cable. Okay, if you lay down and if there is in submarine canyon, there are underwater landslide, it happens, then it will destroy this also. Okay, now extensive Patagonian shelf you will find in the southern hemisphere also. So one of the important characteristics or prominent feature in the Atlantic Ocean is the presence of wide and extensive continental shelf. Clear? Let us go ahead and see the Indian Ocean. The picture which is in front of you is an Indian Ocean. You see here, this is India. Okay, this is India, this is Africa, okay, this is Australia, this is Indonesia. Okay, see, it is Arabian Peninsula. Now you tell me, the picture is already in front of you. After going to the picture of Indian Ocean, what is or what are the prominent features that you observe? One of the observation that you can find from this particular Indian Ocean is it has got a very narrow continental shelf. Okay, it has got a very narrow continental shelf. Why? On the eastern side you have this trench area. I am not explaining what is trench anymore. We have already explained what is trench. In the eastern side you have Sunda Trench, S-U-N-D-A. This is Sunda Trench. Near this Indonesia, you have Sunda Trench. Whenever you have trench, you won't have extensive continental shelf. Now, on the western side, kindly pay attention, very important point. You don't have a trench, but the continental shelf is very, very narrow even in the western side. The reason is, this particular Africa is just like a plateau, African plateau. So they are upraised, and because of this plateau in nature of this African continent, you have a very narrow continental shelf in this region also. One of the prominent characteristics of the Indian Ocean is it will have a deep sea fan in the northern region. In fact, it is one of the largest deep sea fan you will find, that is the deep sea fan formed by the mighty river of Ganga, Brahmaputra, which is coming here, making a delta. Also, the Indus River, which comes and outpours into the Indian Ocean region. Unlike the other ocean of the world, one important characteristic of the Indian Ocean is, in the north, it is completely landlocked. In the north, there is no connection of Indian Ocean to the Arctic region. If you go to Pacific Ocean as well as to the Atlantic Ocean, you will find there is a connection to the polar region. But the Indian Ocean, you don't have any connection with the polar region. That's why any kind of interaction or mixing of the Indian Ocean happens only from the south, from these regions. Okay, that's why Indian Ocean is also known as one of the warmest ocean of the world. If you compare other ocean, Indian Ocean is also considered as the one of the warmest ocean in the world. Why? Because it is completely confined in the north by the land mass. 60% of the Indian Ocean is abyssal plain. Clear? Now, here you will find a Moar region, that is the rich region. The rich region start from the Red Sea region like this. You kindly follow the pointer. Start from the Red Sea region. Now, why this particular rich region is starting from the Red Sea region? Okay, I'm telling you once again, because of paucity of time, I won't be able to explain this in this YouTube session. But if you want to know more about why this Red Sea, from why this particular reach in the Indian Ocean is starting from the Red Sea region, you can always come and join me in my Plus course in Unacademy platform. Okay, there we explain everything in detail. Now you see here. Here it comes down like this. Inverted Y. It forms inverted Y shape. This ridge. Now, this particular part, upper part, is known as Galsberg Ridge. Okay, Galsberg Ridge. C-A-R-L-S-B-E-R-G. Galsberg Ridge. Now, the western part or southwestern part, which is coming like this, it is known as Atlantic Indian Rise, because it is going to join the mid-oceanic ridge of the Atlantic Ocean. The eastern side, which is going like this, it is known as Australia Antarctica Rise. The name is important. Let me write for you. This is Australia Antarctica Rise. Okay, the eastern part. Remember, this ridge which is coming, the upper part is known as Galsberg Ridge. After reaching a point, it is divided into two parts. One runs towards the west, southwest, one runs towards the southeast. The southwest part is known as Atlantic Indian Rise, which is going to join the Amur region of the Atlantic Ocean. The other is Antarctica Atlantic Rise. Australia Antarctica Rise. Clear? Now, at around 90 degree east longitude, you have latitude and longitude. These are the latitude lines. If it is equator, these are the latitude lines. If it is from polar to pole, this line, this is longitude. So around 90 degree east longitude, you have one ridge. This ridge is known as 90 degree east ridge. You will find like this. Other important characteristics is you will find Chaco-Lacative Ridge in this region, that is southwest of the Indian Peninsula. Clear? Here in this particular, there are many island systems, the Lacative Island system also. Okay, now the water bodies on the west side of this, it is Somalian Abyssal Plain, or it is also known as Wartong Basin. Name is very, very important. Between this Atlantic Indian Rise and the Australian Antarctica Rise, it is known as Enderby Abyssal Plain. Remember, 60% of Indian Ocean consists of abyssal plain. Clear? So these are the important characteristics of the ocean bottom relief of the three oceans, that is Atlantic Ocean, Pacific Ocean and the Indian Ocean. We'll end the session here today, but tomorrow we will go and see what are the important characteristics of the Arctic Ocean basin, and also the recent, or the just now, only last year, it has been only this year I guess, recognized, that is the Southern Ocean, the fifth ocean of the world. Till now we have Pacific Ocean, Atlantic Ocean, Indian Ocean and the Arctic Ocean. But the most recent recognition of one ocean, that is known as Southern Ocean, that is around 60 degrees south latitude, covering or circumscribing the Antarctica continent. You have one ocean known as the Southern Ocean. Today we have already covered the ocean bottom relief of Pacific Ocean, the Atlantic Ocean, the Indian Ocean. Tomorrow we will continue with the Arctic Ocean and the Southern Ocean. Clear? Anyways, we'll end the session here today. Thank you very much for your patience and cooperation. We will meet again tomorrow, that is Monday at the same time, 11. Okay? Wish you all the best. Happy weekend. Bye-bye and take care.